¿Están viendo mi pantalla, Javier?
Sí.
Perfecto, ok. Good morning, everybody. Welcome to the ANH workshop number 20, titled "The Present is Not Always the Key to the Past, Exploring and Modeling the Paleogene Internally Drained Fluvial Systems in the Middle Magdalena Valley." Oh my God. Sorry, no problem. 1 minute, please. For some reason, the presentation doesn't move. Let me see. Daniel, can you open your presentation there from there?
Yes, sure.
Yeah, Danny.
Give me a second. I'll be there with you now. Can you see it?
Yes. Perfect. Okay, no, I was just telling everybody that today we are in our ANH workshop number 20. The present is not the key to the past, exploring and modeling the Paleogene internally drained fluvial systems in the Middle Magdalena Valley. We would like to emphasize that this is our first presentation in July. We have a special guest today, Dr. Xavier Roca, who is currently working for Parex. And we have also the pleasure to have here Joana Mendez from Agencia, who is going to talk in Spanish at 8:40. which is going to talk about this nueva convocatoria MinCiencias, financiación de proyectos de investigación que conduzcan a la generación de nuevo conocimiento geocientífico en cuencas colombianas. In July 8, we will have a very interesting workshop. Next week, we will have the ANS presenting giant gas potential in Cretaceous rocks along the eastern cordillera of Colombia. And on July 18, on our workshop number 22, we will have a special guest, Dr. Carlos Macedali from Houston. He was going to talk to us from Houston, and the title of his talk is Exploration Trends and Opportunities in Colombia. That day as well, we will go back to the MinCiencias with our second convocatory, that is just financial young professionals, and it's really, we are going just to reinforce or offer presented last week. On July 22nd, we will have our workshop number 23. We will have the pleasure to have Dr. Alberto Garcia, president of the Drummond Company, who is going to talk to us regarding regarding exploration in natural fracture reservoirs in the Cesar Rancheria Basin, Colombia. And in the last week of July, July 29, workshop number 24, we will have as well a special guest, Dr. Luis Ernesto Ardila, who's going to give us a talk titled Exploration Efforts to Date and a Vision for Future Endeavors. Daniel, go ahead. Well, don't forget that we have already identified the agency around 30 opportunities to be nominated in the future. I mean, so this is the map where you can illustrate where are the opportunities for gas, light oil, medium oil, and heavy oil. As well, you know the address, that is the link, the address, the email address where you can access the information of each specific opportunity, as well as the talks given by the agency in 2021. Next. Well, we have the pleasure to have Javier with us. He is a PhD person. Javier is a Catalan-Canadian stratigrapher with 15 years of experience in the industry. He holds a Bachelor of Science from the Autonomous University of Barcelona, a Master of Science from Ohio University, and a PhD from the University of Western Ontario. Javier joined Parex as a geological advisor in 2019 after working for ExxonMobil for 12 years, both in Canada and internationally. As a stratigraphy specialist, Javier contributed to several projects with an early career focus on detailed reservoir characterization to support several oil sands developments in Alberta. In his last assignment in Houston, he was involved in the Guyana deep water discoveries and several field developments to ensure a fast and effective transfer of assets from the exploration to development companies. His current focus is to provide technical support to Parex exploration, subsurface characterization efforts, with a special emphasis on new play identification. Javier loves working with multicultural teams to provide solutions to complex technical challenges. We have also the pleasure to have with us Dr. Joana Méndez Duque, geologist from the Universidad Nacional de Colombia, Master of Science in Geochemistry and Geotectonics from the Universidad de Sao Paulo, 13 years of experience, professional experience in exploration for oil and gas sector, research, teaching, managing of geoscience projects. Joanna has worked for the Minister of Science, Technology and Innovation since 2015, supporting the structuring of cooperation agreements and call with the National Hydrocarbon Agency. Finally, in this introduction, I would like to mention that next week, just to repeat that next week, we have a workshop number 21, Giant Gas Potential in Cretaceous Rocks along the Eastern Cordillera of Colombia, and we will talk about conventional and unconventional reservoirs. And the last slide that I have the pleasure to show to all of you is that we are announcing the workshop, interesting workshop organized by the agency on July 29, where you are going to see all the Pacific work that the agency and entities as the National University, Geological Survey, Universidad de Caldas, DMAR, PGS are progressing in that part of the country. So details of those talks, are going to be provided to you shortly. Okay, Javier, it's a pleasure for us to have you here. And so I'm sorry, I forgot to tell you that that day of the workshop in Pacific, you can join us virtually or in presence here in the agency. The auditorium is going to be open for all of you. Okay, so Dr. Javier, welcome to our workshop.
Thank you very much for the invitation. It's a pleasure to share our thoughts through this workshop. What I would like to do in the next 40 minutes, see if I can expand this very quickly. There you go. Can you see the screen?
Yes.
Perfect. Yeah. What I would like to do in the next 40 minutes is to share some of our new thoughts on how to potentially look at the polygenic succession of the VMM with slightly different eyes. And if we consider that some of the scenarios that we can conceive have some validity, what would be the implications for exploration, a new place, and also modeling some of the fields in the area. So we've known in the stratigraphic community, we've known for many, many decades that fluvial systems can display two very different drainage styles. We have distributive as well as tributive or contributive systems. But it was around the early 2000s when Google Earth and other softwares allowed stratigraphers to look at the modern sedimentary basins. We realized, and especially Wiseman and colleagues were the first one that noticed that out, that the large majority of modern fluvial basins are accumulating systems that are distributive in nature. Not only a few, but in excess of 90%. This came as a big revelation that has lots of implications, things that we didn't notice. The two main ones were that there's a very good chance, given the predominance of distributive systems in modern basins, that we have across the world, in the whole Phanerozoic, we've probably underestimated the amount of distributive systems in the stratigraphic record. The other big implication is, well, most of our sedimentological stratigraphic fluvial models come from tributary systems, modern systems. They may not be the absolutely best or the perfect example to explain parts of the past. So yeah, this presentation tries to show these implications if we take into account these revelations that are just over a decade old, and we apply them in this case in the Valle Medio del Magdalena, see what implications for the industry we can extract. So before we get into the basin itself, let's quickly review some of the key characteristics of distributive fluvial systems. Normally, we call them DFS. So they are all unconfined. They develop where sediment entry points, or sediment enters a basin in areas of high accommodation. That leads to a very aggradational nature. Radial pattern, different geometries, but always radial from an up-deep apex. And they can vary dimensionally, a lot. They can be the typical little alluvial fence that by definition, normally it's less than 30 kilometers long systems, all the way to, in excess of 700 kilometers. These would be good or the best examples of fluvial megafans. A beautiful modern example is the Ganga megafan in India, in the Himalayan foreland basin, where, you can see a clear change in the positional styles or fluvial styles. The reason it's important to kind of get to the characteristics of these type of systems is that they are very different than tributary ones. So if we use predictions in the subsurface to build models to chase prospects, having the right model can be extremely critical. because there's a characteristic downslope depositional change in DFS that you don't see in tributary systems. By this change, I mean there is a clear progressive decrease in channel size, amount of amalgamation between channels and other architectural elements, and a progressive decrease in net to gross. These are all kind of counterintuitive if somebody's thinking, a tributive system. We do have an increase of fines and a decrease in lateral continuity of the channels, but like more crevasse plays and terminal plays as we move down slope. And as I mentioned just a minute ago, some of the larger systems clearly display that there is a transition as we move down deep from braided to anastomosed to meandering styles. So that's in a nutshell what we mean by these distributive systems. Last thing I'll say on this slide is they can be so large, some of them, like the example of the Ganga Megafan, that when one look at the stratigraphic record may need to zoom out and take a very large regional picture to really make sense of the full architecture and architectural style of the fluvial system. Some of them are so big that if you stare them too close, we may struggle to realize that it's truly a distributive fluvial system. But they are definitely common. Actually, there's more than 700 modern DFS in modern sedimentary basins, and they show that they can develop across all climatic zones. They are not picky. They do like monzonal climates. That's where they really thrive, but they develop in all climates nowadays. When we look at the different tectonic settings, we see that they are also present in all of them. But we do notice that there is a huge proportion of these DFS that develop in foreland basins or compressional settings. They developed in both internally drained and externally drained, endorheic and exorheic. A little bit more nowadays in the externally drained basins, like 58%, but basically it's close to half and half. What is important on these statistics, I think, is that most of the modern, or a large proportion of the modern distributive fluvial systems could fit in a basin similar to the Media Magdalena Valley. If we can see here in most of the compressional DFS are small enough to fit in the VMM. To me, that's, to us, and this is a very interesting observation, because even though we'll try to make the point that not always using the present as the key to the past may be helpful, that actually applies most of the time. And it's difficult to believe for us that if in a modern planet, there is this amount of distributed fluvial systems in basins similar to the VMM, that during the Paleogene, where I'm going to focus the rest of the conversation or the presentation, it's difficult to believe that that was not also the case. Probably different proportions, but we think that the assumption that a large proportion of these systems were present is valid, and it should be explored. So, better, I think, than myself, where the Middle Magdalena Valley is and what tectonic events were responsible for their development. But we find it a beautiful little laboratory to test this idea if distributed fluvial systems may have been underappreciated in the past. We think this is the case, and we actually think this is the case in many, many, many foreland basins across the world, which is exciting because I think it opens new avenues to look at that section with different eyes and try to understand new opportunities. So we're going to focus actually in the northern part of the VMM, where most of the fields in the area are located, some of the most historical ones. And what we've noticed is, and Parex, I think a lot of the industry and part of academia, in most of our conversations, internally and externally, we realize that there is this kind of trend or line of assumption which explains most of the Paleogene field basically as the result of a large axial system. So would be something flowing normally from south to north that tends to, connect most of the producing reservoir, the nice sandy packages. And yeah, it assumes that it's got a tributary nature. It also assumes that it is some sort of Paleo-Magdalena system, which allows us to go back, take facies distributions, dimensional measurements, anything we need to build geocellular models from the modern Magdalena. We think that this is a valid and probably at some stages it's very applicable, but we think that when we take into account a few things, as I said before, the large abundance of DFS in this type of basins, like this, very prone to accumulate these systems. The fact that, as we'll see in the next slide, there is a clear increase of massive accommodation along the eastern part of the basin, logically the result of a tectonic loading and flexure of the lithosphere. This is a perfect setting, the eastern margin of the basin, to develop these type of systems. The other important thing, and that came also pretty much, early 2000s, mostly based on provenance studies and especially the tridal zircons. I think there's a widespread agreement that after the Lisama and starting, like post Eocene unconformity, especially, most of the Paleocene basin was endorheic or internally drained. Probably we are looking at the system, complex systems of constantly evolving mini basins or sub-basins. But if we agree that for several million years we had a closed basin, it is extremely difficult to develop tributary systems, at least large ones, similar to the modern Magdalena. It's much more plausible that, at least for a large part of the Paleogene, distributive fluvial systems were responsible for filling the basin. We think that this is a valid hypothesis. And by the way, I should say, the goal of this talk is to generate some, conversation, some debate. It's offer food for thought to look at old basins with new eyes, rather than, getting into a lot of details. We think there's value in entertaining some of these thoughts. So here, the main hypothesis we're going to investigate is, could a large part of the Paleogene basin field be composed of distributive fluvial systems? So if that is the case, and then we assume that they are progressing from the Eastern Cordillera into the basin, I think a modern analog could work quite well. And this is at the same scale as the map of the VMM. The San Joaquin basin in the US, we feel is probably a good modern analog, where we have like several laterally stacking distributive fluvial systems that could fit easily within our VMM basin. So if this hypothesis has some merit, if we want to investigate it really, what are the implications for the way we model some of the reservoirs in the discovered fields, especially to try to estimate ultimate recover or what uplift it's left in some of these old fields. We would like to share some thoughts on that, as well as how can we identify any remaining potential with this kind of different scenario. So let's see. Given that we have limited time, we decided to focus on the Mugrosa formation. You can see both the full Paleogene isochore map as well as the Mugrosa, it's mostly Oligocene. And we think that's a good choice because it's a good representation or subset of the tapering wedge typical of a foreland basin field that we see for the whole Paleocene. You can see clearly the thickening towards the east, where most, the depot for a deep was located, and the gradual tapering to the west. And in the case of the northern basin, or the northernmost expression of the basin, we have the Miocene unconformity kind of beveling and erosionally truncating the Mugrosa to the north. Okay, so yeah, definitely a system or a succession deposited, under flexure, under foreland basin kind of tectonic setting. So if we want to start digging into the facies and the type of deposits involved in this unit, we think the best way is to go to the type section, and where probably the best exposures of the succession are in the Synclinal del Nuevo Mundo, where Caballero, well, many previous geologists have done great work. But I think what really stands out of the last years is the work that Caballero and colleagues produced for the whole Paleogene. It's a really nice study, very detailed, and in our opinion, it really succeeded at capturing some of the key features to understand these successions. If again we focus on the Mugrosa, we see that we have a massive fast tapering to the west from thinning over 15 kilometers, and I think a reduction of almost 650 meters. Dominated by paleosoils, mostly muddy, but a lot of paleosoils, and a few conglomeratic sandstones, definitely close to the source, given the granulometry. The tridal zircons and all the provenance work suggests that they are exclusively fed from the Santander Massif to the east to northeast, so it's easternly derived fully. And the polyflow direction shows a beautiful kind of fanning or radial southwest to northwest, range of polyflows. And Caballero and colleagues, in our opinion, very logically interpreted this succession as an alluvial fan that progressing into a playa lake, to fill the basin. So, focusing on the Mugrosa again, we go to the type section. We look at the best or reference outcrops, and we see that the latest and greatest work suggests that indeed that formation is a distributive system. So, well, that's a very interesting fact. Next thing we wanted to take a look at is, okay, let's go to the subsurface. Let's move another 30 kilometers or so into the basin, and let's take a look at a very reference or important field like La Sira, with very well basal Mugrosa sands developed. The core available in this field, I think, suggests that the lower Mugrosa consists of multi-story sandstones, interbedded with some finds, all pedogenically altered, some of them with clear evidence of paleosoil development. But overall, an architecture and a facies distribution that and type of depositional environment is involved that seems to be, again, to have more affinity with the proximal part of the distributive system, where you have braided bars, like high amalgamation of fluvial channels, a few remnant paleosoils, preserved. Not that dissimilar, at least in kind of processes, to the expression of the Mugrosa in outcrop, just a few tens of kilometers to the east. So we feel that even though we love to work with multiple hypotheses in trying to explain things, more than one way, we think that the base case interpretation for this type of succession is more proximal, alluvial, very episodic discharge type of system. So in the past, and some of the hypotheses involving a tributary system with a Paleo Magdalena, channel in the La Sira, would suggest that if we take a look at the modern Magdalena deposits, we should see some sedimentological affinity or match or similarity with what we see in the Oligocene basal Mugrosa in this field. So what we did is we leveraged the work that Daryl Smith did back in the 80s. Daryl Smith is a very beloved Canadian stratigrapher here in Calgary, where I'm based. We owe him a lot of critical fluvial observations. He especially, and I'll be leveraging some of his thoughts and ideas and predictions, especially anastomose systems. Daryl Smith was the person who kind of defined the anastomose fluvial model based on observations near Banff National Park here in Alberta. And after he published the original work, the first big fluvial modern system that he decided to study to see, how he could bring, quaternary examples into his work was the Magdalena here in Colombia. The reason being because it's an absolutely spectacular, gorgeous, anastomosed axial system nowadays, from Barranca Bermeja to Calamar. That's more than 500 kilometers. What he saw there is that most of the deposits are actually dominated by mudstones and things that are more a floodplain, ephemeral lakes. 70 to 90% of the succession is unbioturbated, unpedogenically altered, fine-grained, floodplain deposits, let's say. When he encountered some of the channels, he saw that they were way more gradational than what we see in La Sira. Here, the modern channel fields can reach 30 meters in thickness. In La Sira, rarely exceed, like 5. And yeah, there is a, absence of paleosoils, an abundance of ephemeral lake deposits, as I said, lacustrine, these type of things. Definitely not what we see in La Sira. Therefore, we think that this is some evidence, or these observations really supports that La Sira and the Mugrosa time fluvial systems in the VMM are probably not a proto-Magdalena. We probably don't want to use the modern or the present as the key to the past, at least in the Oligocene. That's for tributary versus distributive anastomose systems. But when we look outside the La Sira in other, fields where, the succession is a bit more less sandy or less, spectacular from a reservoir point of view, but a bit more paradigmatic or, let's say, representative of the rest of the Mugrosa throughout the basin. And this is one of the examples. We do see that there is a lateral connectivity, or sorry, continuity of paleosoils that allow, a rudimentary but useful correlation approach. And let's zoom in one of these where we have like good core coverage, and let's take a look at the facies. Are they more similar to what we see in La Sira or outcrop, or are more similar to the modern Magdalena? Here you have basically the breakup in different facies, or in this case are interpreted as architectural elements for this Mugrosa core. And what we can see, and this is just an example, we've seen that in quite a few others, is that similar to the modern Magdalena, there is a predominance of unconfined, like floodplain deposits, ephemeral lakes, lots of crevasse plays, and a few paleosoils. Quite often we can see that it's actually there's a basically alteration of originally like floodplain or ephemeral lake deposits. So even the paleosoils have a genetic origin that is more, floodplain. This is typical of a variegating system like the modern Magdalena, but with the difference that the dimensions are very, very, very different. These are not that thick, the channels. These are much more consistent with the distal expression of distributive fluvial systems, where crevasse plays are the main reservoir sands. Channels are very thin, low energy. So, I don't have time to get into some of these details, but the sands in the channel fields are telling us that these things were moving with very slow velocities. Again, common of decelerating flows in distal parts of the distributive fluvial system, and not of modern trunk large systems as the Magdalena nowadays. So we think that anastomose systems are probably responsible for the deposition of most of these Mugrosa facies. And here we'll show you a couple of schematics that some of the classic mile fluvial publications. Mile took this concept from Daryl Smith and really expanded it because it's got a lot of merit, and there's quite a few systems, especially here in Canada, that have this style. They look like that, and they're interesting to model because, as you can see, the lateral connectivity of the sands is challenged. It's there. These channel fields or little spaghettis of sand, if you want, they do touch here and there, but a water flood on this type of channelized systems is not easy unless you have the ability through seismic to put your injector and producer exactly where the right architectural elements are. Given the dimensions of these and the frequencies we normally play with in seismic, these are invisible to us. This needs to be predicted. So when it comes to building models to get recovery factors or understand what the connectivity of the system is and how to optimize a water flood, this is very challenging. And we are basically required to lose a lot of conceptual work, modern dimensional databases, modern analogs, everything we can use to produce a realistic model that can be simulated with some degree of reliability. What we suggest, that's the way we like to approach it, is instead of building a massive full field model of several hundred meters, many stacked different anastomose systems. We do see point bars and other things, but we think that anastomose systems are the dominant fluvial style. Instead of doing such a monumental piece of work, which takes time and it's very difficult to simulate, our approach is to focus in one of the cycles, and that seems to be a representative of the rest, and try to model it as realistically as possible. We know that the model is not perfect, but we're trying to use parameters that are realistic, and as we play with sensitivities, can give us some simulation results that are more reliable. Especially, we want to emphasize that the connectivity of the different channels needs to be not stochastic, but it needs to be basically decided and ensure that it's like similar to modern anastomose systems. So to do that, what we do is basically define these channels with polylines, inspired with the dimensions and and geometries and kind of spacings that we see in modern analogs. We really want to make sure that our little model, fits in the regional context. In this case, for the Mugrosa, like the larger paleoflow, facies distributions, as well as production data that in quite often give us a sense where the main flow of the system was directed. We use a lot of global databases to estimate, since we cannot see the channels. We do see the thicknesses in core and logs, but we use global databases to estimate the ranges of the widths. And this way, we ensure that we are not introducing non-geological kind of parameters to the model. And yeah, we prefer to build facies-based poroform distributions once we've defined the different architectural elements and we've managed to distribute them in a realistic way. As you can see here, channels, levees, crevasse plays, which they all offer their own a little bit of connectivity. But basically, what we see is we try to create, this is our porosity, this is our permeability. With time, we'll try to play with sensitivities and create several of these sector models to get a range of results and simulations. But we feel that, yes, this is not a perfect model, but it's a much more realistic connectivity and therefore reliable results that just using a stochastic model that sometimes we've done. We've all done that, especially in fields with a lot of wells. But when it comes to simulating this type of anastomose systems, which are not forgiving, if we don't come up with a realistic approach, we feel that the results are very unreliable. The other important thing here is that if we do assume that most of the fields are actually distributive and anastomosed, but not, like as large as the proto or the current Magdalena, the main implication is that our in-place volumes may not be as large as we hoped or we expected. And some of the recovery factors that we see are actually relatively close to its ultimate one. That would not apply for, absolutely all of the Mugrosa, but I think it's an interesting thought for a lot of the stratigraphic succession of this unit. Just a thought, because it's got big implications, I think, on how we, decide to kind of extend the life of some of these phenomenal fields. Just some food for thought. The other thing, and to start wrapping this up, anastomose systems have come to the, I think, well, they were originally defined in the mid-'80s, so they are still relatively new. In Canada, because, like we grow up with these guys, we are quite familiar, and we are not shy and interpret things as anastomose. But in many other parts of the world, it's a concept that it's kind of making its space into the palette of interpretations for the international stratigraphers very slowly. Just a couple thoughts. What we need to develop these systems is a very fast accommodation and enough fine-grained material like mudstones to basically stabilize the channels. But one of the most fascinating things, and you can see that this is a cartoon of the Alexander River where Daryl Smith defined the anastomose model in '83, if I'm not wrong, or 80. So basically they evolved from braided systems, okay? That is the same, and this is a tiny little, like DFS in Alberta. You can go to, several, that's what, 150-kilometer long Ganga megafan, and you see exactly the same. There's a facies belt where the fluvial style is all anastomosed, and it's basically the down deep evolution of a braided system. Okay, so one of the interesting thoughts here is, could this be evidence that up deep of where we see some of these anastomose systems in the Mugrosa, actually, there is an up deep braided system feeding the anastomose one? I think that's an interesting thought that can have applicability in some of these systems and may suggest that in the eastern part of the basin, now, structurally deformed and where some structural traps are present, the Mugrosa and other parts of the Paleocene could have actually really interesting reservoir, reservoir facies. Can we explore for those? Can we find some of these guys, undiscovered so far? Well, that's something that we are considering, and it's part of the new ideas that we want to test. But I would like to leave you with a quick thought. If this DFS, Eastern or Western prograding DFS hypothesis has some validity, we should start looking for some alluvial facies, or, like big stacks of sand, like very coarse alluvial conglomerates. And when you go to the northernmost part of the, the outcrop belt, close to the northernmost, limit of the Mugrosa, both in the Sucio River and Lebrija River, we see both things. We see, and not only in Mugrosa, but, like from actually Lizama to, Esmeraldas, we do see massive stacks of multi-story sands, which are not that common in the subsurface. And we do see, again, from Lizama to Esmeralda, very, very coarse clastics, which we at least have not been able to find in other parts of the basin. So we think it's fairly unlikely that an axial north-directed, system kind of moved systematically in this area. Not impossible, but we think that it's much more likely that these deposits are the result of several distributed fluvial systems that prograding through this area, probably the northernmost part of the basin, which is an easy place for a fluvial system to enter a basin. And in this case, probably would be more like west to southwest directed, just a hypothesis. But we think that this is very encouraging. And this is thanks to Geocuencas, who did all the field work for us. They are our eyes in the field quite often. But we think that this is not diagnostic, but very supportive that the DFS hypothesis has some validity. And, it's interesting to pursue this line of reasoning, because some interesting opportunities may remain, if some of part of this hypothesis at least is true. So to conclude, 4 main thoughts. For us, is extremely interesting the fact that DFS dominate, by dominating, I mean like more than 90% of the fluvial record entering, deposits entering the record nowadays. Probably that applied, in the past. The Mugrosa Formation has several fluvial styles, but we feel that the anastomose style is the most representative and volumetrically the most important, or most abundant. Modeling it and treating it properly is important, because if we assume that these systems have the dimensions of the modern Magdalena rather than skinnier guys that, in our opinion, most of the data suggests, we are running the risk of overestimating volumes overestimating the potential left. And finally, as I mentioned at the end, the upside is there's a good possibility we feel that there's still some proximal DFS facies involved in some structural traps along the western part of the Eastern Cordillera that may lead to some interesting discoveries in the near future. So thanks for the time. I hope I'm close to the 40 minutes. I'm happy to answer any questions or, at any time, any conversations. I'm happy to. This is just an exercise in, sharing some thoughts and providing some food for thinking. So if anybody's interested in continuing the conversation, we are happy to do that. So thanks again for inviting me to present in this workshop, and that's it. Thank you very much.
Thank you, Cheryl, for the presentation. And ANH would like to say thank you to you. And now I would like to give the stage to Joanna for the presentation about incidences. And I'm quite sure that meanwhile, if anyone got a question, surely we could maybe answer it in the chat. So that's the dynamic. So thank you, Cheryl, again. And now we give the stage a Joanna para la presentación. Muchas gracias.
Buenos días a todos, ¿me escuchan fuerte y claro?
Sí.
Listo, voy a compartir pantalla. Por favor, me indican si están viendo mi pantalla.
Sí, se ve, Joana.
Listo, bueno, primero que todo agradecer el espacio a la Agencia Nacional de Hidrocarburos para difundir la convocatoria. La convocatoria es la 931, el título de la convocatoria es Convocatoria Fortalecimiento Actores Industria Hidrocarburos. Esta convocatoria nace de un trabajo conjunto con la Vicepresidencia Técnica y la Vicepresidencia de Operaciones, Regalías y Participaciones de la agencia, por lo tanto es una convocatoria que abarca muchos temas. El objetivo principal es fortalecer las capacidades en investigación en áreas relacionadas con el sector de los hidrocarburos en Colombia a través de la financiación de proyectos de I+D+I, así como la vinculación de jóvenes investigadores e innovadores que permitan la generación de nuevo conocimiento geocientífico del sector de hidrocarburos, el aprovechamiento sostenible del recurso hidrocarburífero y el fomento de vocaciones científicas en el área de geociencias afines al sector de hidrocarburos. Esta convocatoria cuenta con la financiación de varios convenios suscritos entre el Ministerio de Ciencia, Tecnología e Innovación y la agencia, por lo tanto, lo que hicimos fue dividirla en modalidades de acuerdo con los objetos de esos convenios. Entonces, las tres modalidades que tenemos para financiación es la primera, que es proyectos de I+D+I, investigación, desarrollo e innovación, que conduzcan a la generación de nuevo conocimiento geocientífico en cuencas colombianas, dirigido a apoyar propuestas de proyectos de investigación en la consolidación del conocimiento geocientífico en cuencas del país. La modalidad 2, cuya fuente de financiación proviene de uno de esos convenios, es para la financiación de proyectos de I+D+I que propenden por el aprovechamiento sostenible del recurso hidrocarburífero en conjunto con la vinculación de jóvenes investigadores. Esta modalidad está dirigida a apoyar propuestas de proyectos de investigación en temáticas que apoyen el desarrollo sostenible del recurso hidrocarburífero, así como el trabajo en cuencas de zonas frontera. Para estos temas se considera fundamental la articulación con la de iniciativas de jóvenes investigadores, la cual está dirigida a jóvenes de pregrado y recién graduados de hasta 28 años. La modalidad 3, que es para financiar iniciativas de investigación para fortalecer las vocaciones científicas en el área de geociencias, está orientada a vincular semilleros, jóvenes de pregrado y profesionales recién graduados con formación en geología, geociencias, ingeniería geológica, ingeniería de petróleos o programas afines a ciencias de la tierra cuyas disciplinas tengan relación directa con estas y con la investigación del conocimiento geocientífico del sector de hidrocarburos. Por lo tanto, es muy importante que cuando ustedes apliquen a la convocatoria, primero sepan a cuál modalidad van a presentarse. La primera es solamente para financiación de proyectos de investigación. Bueno, en los términos de referencia se encuentran las líneas temáticas específicas. Para la modalidad 2 se financian proyectos, pero es obligatoria la vinculación de jóvenes investigadores. Y la modalidad 3 es exclusiva para todo el tema de vocaciones y vinculación de jóvenes investigadores y de semilleros de investigación. Las modalidades 1 y 2, que son las dirigidas a financiar proyectos de investigación como tal, va dirigida a grupos de investigación, desarrollo tecnológico e innovación reconocidos por el ministerio, es decir, con reconocimiento vigente al cierre de la convocatoria. Se pueden presentar en alianza, pero esto es opcional, con otros grupos de investigación, otros actores del Sistema Nacional de CTI, o instituciones de educación superior o centros de investigación y desarrollo tecnológico internacionales. Para la modalidad 3, que es la exclusiva para los jóvenes investigadores, esta modalidad va dirigida a actores reconocidos del Sistema Nacional de CTI o entidades del Gobierno Nacional o instituciones de educación superior que cuenten con grupos reconocidos por el Ministerio. Ese reconocimiento debe estar vigente a la fecha de cierre de la convocatoria. Para la modalidad 1, que es la exclusiva para financiar proyectos de investigación, contamos con dos grandes líneas temáticas. La primera es yacimientos no convencionales, la cual tiene dos sublíneas. La primera, que es identificación del potencial de yacimientos no convencionales en las cuencas del Cesar Ranchería, Valle Medio del Magdalena, Valle Superior, Cordillera y Catatumbo. Y la segunda sublínea es geomecánica enfocada al desarrollo de yacimientos no convencionales. La segunda gran línea temática es la exploración de cuencas frontera y emergentes. Tiene 5 sublíneas, voy a mencionar solamente algunas por temas de tiempo. La primera es identificación de oportunidades exploratorias para hidrocarburos en las cuencas frontera offshore Caribe, offshore Pacífico, Chocó, Tumaco, Cauca-Patía, Cordillera, Urabá y Amacá. Bueno, ustedes pueden consultar con más detalle los términos de referencia. Ahorita les muestro cómo pueden ingresar a la página para poder tener acceso a los documentos. Con relación a la modalidad 2, que es la que tiene financiación del proyecto, pero también la vinculación obligatoria de jóvenes investigadores, tenemos 6 grandes líneas temáticas, voy a mencionar algunas. La primera es modelos hidrogeológicos conceptuales en zonas de alta sensibilidad social y ambiental. Tenemos también la línea de hidrógeno, la de captura, utilización y secuestro de carbono. Para la modalidad 3, que es la exclusiva para la vinculación de jóvenes investigadores y semilleros, esta línea está abierta a diferentes temáticas. Se mencionan algunas como temas de guía para los proponentes, como por ejemplo identificación de oportunidades exploratorias para hidrocarburos en cuencas frontera, o definición de trampa, reservorio, roca fuente para hidrocarburos en cuencas frontera, tanto onshore como offshore de Colombia. Para esta modalidad se pueden presentar en las 23 cuencas colombianas. Sin embargo, se les da 5 puntos adicionales a los proyectos o a las propuestas de los jóvenes investigadores que se presenten en cuencas frontera. Esto con el objetivo de incentivar la investigación y la generación de nuevo conocimiento en estas cuencas. El recurso que tenemos disponible de financiación para esta convocatoria en general es de 25.235.714.061 pesos. Para la modalidad 1, que es la específica para la financiación de proyectos de investigación en cuencas colombianas, tenemos 7.700 millones aproximadamente para financiar. Para la la gran línea de yacimientos no convencionales tenemos 1.752 millones aproximadamente. Esperamos financiar 2 proyectos. El monto máximo a financiar por proyecto es aproximadamente de 876 millones. Y para la gran la gran línea temática de exploración de cuencas, fronteras y emergentes tenemos 5.967 millones aproximadamente. Esperamos financiar mínimo 4 proyectos. El monto máximo a financiar por proyecto es de 1.500 millones. Para las 2 líneas, la duración máxima de los proyectos es de 18 meses. Para la modalidad 2, que es la financiación de proyectos con la vinculación obligatoria de jóvenes investigadores, tenemos varios montos de financiación máximo, dependiendo la línea y la sublínea de investigación. Es obligatorio vincular mínimo 1 y máximo 3 jóvenes investigadores, y la duración máxima de los proyectos es de 12 meses. Para las modalidades 1 y 2, que es la financiación de proyectos, se financia hasta el 80% del valor total de la propuesta. Las entidades proponentes deben aportar mínimo el 20% del valor total de la propuesta, ya sea en dinero o en especie, deben colocar una contrapartida. Bueno, los centros autónomos, institutos públicos reconocidos por el ministerio, no están obligados a ese aporte de contrapartida. Para la modalidad 3 tenemos un recurso de 4.500 millones. Para esta modalidad tenemos 3 mecanismos de financiación. El primero es financiación de beca pasantía en investigación de jóvenes investigadores innovadores de pregrado y profesionales recién graduados. Ustedes pueden consultar en los términos de referencia cuál es la definición de joven investigador, ya que tiene unos requisitos tanto de edad como de estado académico y de promedio. Y para profesionales recién graduados, que también tienen unos requisitos, que pues tenga máximo 3 años de graduación hasta el 31 de diciembre de este año. Para el mecanismo 2, que es la financiación de trabajos de grado, de estudiantes de pregrado, los requisitos también se encuentran en los términos. Y el último mecanismo, el 3, que es la creación o fortalecimiento de semilleros de investigación, desarrollo e innovación de estudiantes de pregrado. Dentro de los términos, en el anexo 3, creo, bueno, sí, en el anexo 3, ustedes pueden encontrar cuáles son los ítems mínimos que deben tener los proyectos que se presentan. Bueno, acá menciono algunos: estado del arte, marco conceptual, metodología, cronograma, y que se financia. Aquí, entre otros, los rubros que se financian son personal científico y de apoyo, equipos que estén justificados técnicamente su adquisición, materiales e insumos, material bibliográfico y adquisición de datos. Aquí resalto este tema porque dentro de este rubro pueden incluir todos los gastos relacionados con la compra de información al EPIS. Recordemos que de todas maneras el EPIS cobra por el tema de la transferencia de la información, y pues esa es una de las maneras en las que tiene el servicio biológico para financiarse. Para que lo tengan en cuenta en el presupuesto que ustedes incluyan, porque a veces no lo colocan y posteriormente les toca comprar los datos y el presupuesto no les alcanza para esa adquisición de información. ¿Qué más financiamos? Servicios técnicos especializados, software especializado. No financiamos procesadores de texto, sino software que realmente sea científico y que se requiera para el proyecto. Asesorías especializadas, actividades de difusión, salidas de campo, eventos, publicaciones y patentes. Jóvenes investigadores, obligatorio para las modalidades 2 y 3. Gastos de operación, que es hasta el 7% del monto total que ustedes piden para financiar el proyecto. Estos son algunos de los rubros. Ustedes pueden consultar con más detalle en la página. La convocatoria abrió el 24 de junio, el viernes pasado, cierra el 19 de agosto a las 3 de la tarde. Por favor, tener muy en cuenta la hora para que no los coja el tiempo, porque generalmente pues hemos visto que inscriben los proyectos a último momento, la plataforma se colapsa y tienen luego problemas para inscribirse. Y el sistema es automático, se cierra a las 3 de la tarde, si no alcanzaron a inscribir el proyecto, pues no pueden participar en la convocatoria. Hay un periodo de ajuste de requisitos o de subsanación en la cual los documentos que les hacen falta, ustedes pueden consultarlos en nuestro sistema integrado de gestión de proyectos para que puedan subsanar esos requisitos y continuar a la fase de evaluación. Hay una publicación del Banco Preliminar de Proyectos de Elegibles el 14 de octubre y finalmente la publicación del Banco Definitivo de Proyectos el 11 de noviembre de este año. Cualquier duda que ustedes tengan, pueden dirigirla al correo que les estoy colocando aquí, atencionalciudadano@minciencias.gov.co, ya que ese es el canal oficial de atención al ciudadano que tiene el ministerio. Aquí les voy a mostrar un poco pues cómo pueden ingresar. Entran a la página de MinCiencias, minciencias.gov.co, oferta institucional, programa de oferta institucional y se van a programas y proyectos de CTI. Ahí les aparecen todas las convocatorias o todos los instrumentos de CTI que se encuentran abiertos. En este momento, pues nosotros estamos de primeros, es la 931. Hacen clic sobre el nombre. Y aquí pueden consultar los términos de referencia y cada uno de los anexos, también el cronograma de la convocatoria para que lo tengan muy en cuenta. Dentro de los términos dice pues cuáles son los canales o los correos para ustedes dirigirse. Esperamos próximamente poderlos invitar a una charla de lanzamiento de la convocatoria. Probablemente se haga la próxima semana o el día 11 de julio. Estamos mirando, la cual se realizaría por YouTube. Entonces, a través de los correos masivos, por ejemplo, de la Asociación Colombiana de Geólogos y Geofísicos del Petróleo, la Sociedad Colombiana de Geología, vamos a remitir la invitación para que se presenten al lanzamiento. De igual manera, les recomendamos leerse muy bien los términos de referencia antes de la presentación para que lleven todas sus dudas y podamos aclararlas y puedan participar activamente en la convocatoria. De nuevo, muchas gracias a la NH por darnos este espacio y esperamos una participación masiva de toda la comunidad para fortalecer las capacidades técnicas y científicas en el sector. Gracias.
Joana, muchísimas gracias por esta presentación. Estamos seguros que toda la comunidad académica, tanto estudiantes como grupos de trabajo, estarán muy interesados en estas convocatorias. Recordarles brevemente a toda la gente que está el día de hoy que nuestra próxima presentación del mes de julio sigue con la parte de potencial de campos gigantes de gas en el Cretácico a lo largo de la cordillera oriental de Colombia, citada por César Mora. Después tendremos en julio 15 al doctor Carlos Macerali con nosotros para los Exploration Trends and Opportunities en Colombia. También hablaremos de la convocatoria MinCiencias, financiación de jóvenes investigadores. El 22 de julio tendremos como invitado especial al doctor Alberto García de la Drummond. Y en julio 29 tendremos al doctor Luis Ernesto Ardila para los esfuerzos de exploratoria a la fecha, para una visión a futuro. Si alguien de pronto, tenemos un par de minuticos, tiene alguna pregunta para Joana, sería muy chévere que lo hiciera en este momento. Si no, por los medios que ella de correo ya ha especificado para cualquier tipo de duda o de sugerencia. Bueno, Joana, parece que no hay preguntas. Darle las gracias nuevamente a Xavier por esa magnífica presentación para hacer caracterización de la parte del paleógeno, teniendo en cuenta muy presente cada uno de los subambientes de la cuestión fluvial para la parte del paleógeno en el Valle Medio del Magdalena. Muchas gracias a Joana por toda la información, que como lo mencionaba, mucha gente estará muy interesada. Muchas gracias a todos y nos vemos dentro de 8 días con esta presentación de César Mora. Gracias.